Talking about conditional probability. So conditional probability contains a condition that may limit the sample space for an event. Your sample space is how many total, basically, that you're dealing with. We write our conditional probability using the notation P, standing for probability, of, using a parenthesis, some event B given is just this line, some event A. And this reads the probability of event B given event A. So here below we've got some conditional probability written in a table form, and we are going to find the conditional probability for this piece that they're asking for. So this time they ask find the probability of someone owning a pet given that they are female. So remember, this is the event B right here, while this is the event A. So event A happens first, right? We talked about this back with independent and dependent events. So I'm going to have to look at event A to limit what happens for event B. So it says that our event A is the fact that they are female. So that would be this sample right here, right? All of those are female. So how many females do we have? 14. Okay? So we are limiting ourselves to the fact that there are 14 females for our group. So I don't care about the males. They are not part of my sample space, because according to event A, I'm only supposed to be looking at the females. Okay? So there were, 12 males? Those are not part of our sample space. We're only worried about the 14 females. Okay, so here, we would say that the condition female is what is going to limit our sample space. So our sample space originally would have been all of the people here, but now we know that we're just limited to the females. We have limited our sample space to 14 possible outcomes. All right. So event A was that we were talking about females, so we know we're not considering any of the males. Event B is how many of those females will own a pet. Well, if we look at the graph, we have restricted it to females, so how many said yes to owning a pet? 8. So I only care about the females, not the 5 males. So I can say of the 14 females, 8 of those own a pet. Therefore, we would write the probability for this particular question as probability of what they said, owning a pet, given that we are only looking at females, as a probability of 8 out of a total 14 sample size. All right. Okay, let's look at another one. Okay, this next one says, find the probability of a male given that they wash the dishes. So this time, this is my event B, this is my event A. I always look at event A first. So, what am I looking at? The people that said yes to washing dishes. So that'd be all of these people, right? So what is my sample size? 14. So my sample size is 14. The condition washing dishes told us that. So the condition wash dishes limits our sample size to 14. Okay? Now that I know I'm only looking at the people that said yes, which was 14, I now am told to look at event B, which was the males that wash dishes. So how many would that be? 7. So here, I find that 7 out of 14 wash the dishes. So I can say then that, therefore, the probability of this particular event, males, given that they wash the dishes, is what? What fraction? What is it? 1/2, right. 7 out of 14, which simplifies to 1/2. Very good. Okay, now for this next one, I'm going to pull up a slide and I'm going to talk us through, but you won't have to write it on your notes. Hold on just a second while. Okay, so for this next example here, it says using the data in the table, we're going to find the probability that a sample of not recycled waste was plastic. So they wrote it out as the probability, where event B is that we're looking at the plastic. Event A is that I'm looking at the non-recycled. Okay, so what is going to tell me my sample space? The non-recycled. So what would I need to do with the non-recycled to find my sample space? Add them all up. Good. So since the non-recycled is going to give us our sample space, we are going to add all those pieces up. Okay? So I add them all up, and then I'm told that I'm supposed to, within that group over here, be looking at just the plastic, which would be the 20.4 part, right? So I would end up with 20.4 over this entire column added together. So I add them together. This is what we get. Typically, we will convert it to a decimal, which could be written as a %. But we would say here that the probability of the non-recycled waste for plastic was about 13% because of the decimal we get here. So just remember that we can convert those fractions into decimals and percentages as well. All right? Okay. So for our old material, we said that for 2 independent events, we had a formula. And for 2 dependent events, we had a formula, right? So our formula for 2 independent events, remember, was some probability of A times some probability of B, right? This was when the 2 events were completely unrelated, like rolling a dice and spinning a spinner, right? But if our events were dependent, we said that that was going to affect that second fraction that we came up with because the sample space probably changed, as well as the number you're picking out of could have changed. So we said that this one was the probability of A times the probability of B after A, or the probability of B given A. So we've already been using this idea for some time. We just were just using it for 2 specific samples, while our chart that we just looked at with the recycling could be for a whole bunch of different samples. So they say that we are going to use this formula to find the missing data for this question. It says that researchers asked people who exercise regularly whether they jog or walk. 58% of respondents were male. 20% of all respondents were males who said they jogged. Find the probability that a male respondent jogs. So here they're telling us what our events are. That a male respondent jogs. Those are my events A and my events B. All right, so what did they say the probability was that they talked to a male? 58%. So that's what's going to go right here. Okay. What did they say the probability was that it was a male and that they jogged? 20%. Good. So that would mean our event A would be that they are a male. And our event B would be that they jog. We're trying to figure out just the fact that it's someone who jogs and is male. Okay? So our formula, we know for the two events, so the probability of event A and event B is the formula that we've just been using on the previous problems up above for some dependent events. The probability of A times the probability of some event B given A. So I'm just going to substitute in what I know and solve for what I don't know. All right, so probability of A and B. Do we know the probability of A and B, a male and jogs? Do we have a number for that? 20%. Good. So how do I write 20% as a decimal? Good. So I am going to substitute that in for this part of my equation. All right? Then I've got the equal sign. Probability of A. Well, our event A is that it was a male. Do we have a number to plug in for that? 58%. Yeah, 0.58. Good. And I'm supposed to multiply this times the probability of B given A. That's the part we don't know. Okay? So we're saying, yes, this is the group. This is the likelihood that they are male and jogs, but we're wanting to know out of B only given that sample space A. All right, so all I have to do here is solve. So if I wanted to get probability of B given A by itself, how do I get rid of that 0.58? Divide. So I would have 0.2 divided by 0.58 is equal to the probability of B given A. What do we get when we divide 0.2 by 0.58? So approximately 0.344, something like that. Okay, so we would say that this would be about 34%. All right, let's flip it over onto the back and do one more together. Okay. This one says, researchers asked people if they drink soda regularly and whether they prefer regular or diet soda. 40% of all respondents were people who said they drank and preferred diet soda. 60% of all respondents said they drank soda. Find the probability of a respondent who says they drink soda and drink diet soda. So drink soda is my event A. Drinks diet must be my event B. Right? So, do I have something or some value for drinking soda? Do I know what percent of people drink soda? 60%. Okay, so I have something for here. Do I know what percent of people drink soda and drink diet? 40%. Okay, so my event A is just the drinking soda, while my event B is that they drink diet soda. So I would write my formula, All right, our formula is the probability of event A and B. You can plug in what events A and B actually are. Here, that would be drinking soda and that its diet would be equal to the probability of event A, which is drinking soda, times the probability of event B given A. So the probability that they drink diet given the group that drinks soda. So this 40% here is 40% out of everyone we sampled. We want to limit our sample space to just the ones that said they actually drink soda. That's what we're doing here. All right, so we would substitute in the information we do know. So do I have something to substitute in for a probability of drinking soda and it being diet? 40%, 4.4, is equal to the probability that they drink soda, which is 0.6, times the probability of B given A. So again, what am I going to do to solve for that? Good. All right, and what do we get when we divide by 0.6? Okay. Approximately 0.667, which would be about 66.7%, right? So we could make the statement that the probability that a respondent drinks diet soda is about 66.7%.